And we're going to just take a few questions that are there on the left. You can practice that exact question. We're going to give you a question practically identical to it, okay? So in a very similar question, we have an angle, let's say 60 degrees instead of 70. X, and let's say this is a 4.3 centimeters. And we're asked to write sine 60 as a fraction. So we want to get sine 60 degrees equal to something over something. So what's my fraction going to be? I'll better label my triangle first. So my longest side, hypotenuse. If I position myself here and go across, that's my opposite to the 60-degree angle. And so the side that's left is the side that's adjacent to the 60-degree angle. So I've labeled my triangle. And I also need to know my SOH, CAH, TOA. That's my Sokotoa, or silly old Harry caught a herring trawling off America. This is telling me the sine of an angle is opposite of hypotenuse, cos of an angle is adjacent over hypotenuse, and tan of an angle is opposite over adjacent. So when I look at my orange triangle here, do I know everything? Do I know an angle? Yes, I do. 60-degree angle. That's perfect to know that. Do I know the opposite? Well, don't know it, but I want to know it. So I'll give that a tick, yeah. Do I know the hypotenuse? Yes, I do. So I'll give the hypotenuse a tick. And do I know the adjacent? Well, not at the moment, and I don't particularly need it right now, so I'm giving that an X. So the formula has all three parts is sine. Indeed, that's what they're asking us to do here. So we have all the bits we need. Maybe we didn't even need to do all our ticks, just running through that for practice. Okay, so our opposite anyway. We need the opposite, that's X, and we need the hypotenuse is 4.3. Now sine is 60 on the calculator. I can look that up. So I'm just typing in sine 60 equals, and it's giving me root 3 over 2. So I've got root 3 over 2 is equal to x over 4.3, or if I hit my SD button, most people prefer the decimal, so 0.866025, blah 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 blah. Now leave the decimal on the screen of your calculator, don't go rounding it off. So I want to know x. Well, x at the moment is being divided. This is a division here, fractions mean division. Remember, the fractions mean division, it's always the top divided by the bottom. Okay, that's what a fraction means. So if that's dividing and I want to get rid of the 4.3, I better start multiplying by 4.3. So remember, if you divide something by 4.3 and multiply it by 4.3, well, the number won't change. This is why I'm left with x. Essentially, you're getting 4.3 over 4.3 in here. That's what's happening. You're getting the number 1. Anyway, the bit on the right we don't have to do in the calculator. It's only the bit on the left. We need to multiply that decimal we have by 4.3, and it comes out as 3.7239 blah blah blah. So if we were asked maybe 2 decimal places or something, we would get 3.7. Anyway, let's go back to the question. We weren't even really asked to find anything there. We were just asked to write sine 70 as a fraction in our example on the left. So once we wrote sine 60 as a fraction, we kind of had ticked that first part, A, done. B, using your calculator, find the value of sine 70. Well, once we did this, we'd answered part B. Okay. And a correct 1 decimal place, I suppose. If we wanted a correct 1 decimal place, we better round it off to 0.9. Okay, so if you're asked to round off, you round off. Okay. Then use your answers from A and B to find x. Well, they're just asking you to solve that equation, which we have done. Okay, so look, we've done a bit of work there. Maybe I did a bit more than I had to, whatever. Okay, so let's just park all that aside for a minute. So we can kind of take a look at another question. Okay, so our new question, we're going to do a question very similar to this. Okay, so got a triangle with angle B in it. Write down the hypotenuse. Okay, that couldn't be any easier. So if we take it very similar triangle for ourselves. Let's say we'll say ours is 12 kilometers, 8 the right angle, and we'll label ours B as well, why not? Let's write down the hypotenuse of R1. Well, the hypotenuse is always the longest side, so there's our hypotenuse, okay? So the hypotenuse in R1 is 12. Well, it won't take a genius to figure out the hypotenuse over here. Which one is it? Anyway, part 2. Angle B is marked on the diagram. Write down the length of the side opposite B. So again, we just need to position ourselves at angle B and run straight across, or look straight across the weird triangular room. So we can see our opposite. Opposite B is 8 kilometers. So that's kind of like answering part 2. So we've got like part 1 and part 2 done. Part 3, find sine B. Now we know that sine, silly old Harry, sine is opposite over hypotenuse. I should really have an A in there or something, sine of an angle. So sine is opposite of our hypotenuse. So we need to have our opposite at the hypotenuse, but we just found our opposite a minute ago. This was opposite B, and the hypotenuse we labelled very early on was 12. So we're looking at 8 and 12. So it's just 8 over 12. That's it written down as a fraction. And that particular fraction can simplify down to 2 over 3. So we should maybe... Okay, so we found sine B as a fraction. Okay, in our case, oh, sine A I labelled it. Should have labelled it sine B, yeah. Silly me. So sine B. Okay, so sine B. Part 4, use your answers from part 3 to find the sides of angle B. Give your answer to the nearest degree. So let's find, if we have the expression now, the sine B is equal to 2 over 3. That's the expression we're working with. We just need to get the inverse sine of both sides using a calculator, really. Okay, that's what we're going to be doing. But that's what mathematically we're getting the inverse sine of both sides. On the left we don't have to do anything. They'll just cancel each other out. We're left with B. On the right hand side though, to get this we just need to go shift in the calculator, sine, and then stick in our fraction 2 over 3, and close your bracket or whatever, and hit the equal sign. 41.8103 blah 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 degrees. Now just be careful your calculator's in the degree mode, has the D at the top of the screen. If it isn't, hit shift mode and then choose number 3. So shift mode and then 3. That'll get it in degrees. Other things to be careful of. The question it asks the nearest degree. So what's the nearest degree here? 42 degrees. Okay, so B is approximately 42 degrees, or it is equal to 42 to the nearest degree. Okay, so that was kind of a nice little simple example. Here we've got a question with a house in it. Doesn't really matter what it is. Could be the sail of a boat, could be the side of a skip, could be a ramp, could be lots of things obviously. Anyway, part 1 asks write down the value of tan A as a fraction, and we can see our information is it's 3 meters tall and 4.5 meters long at the bottom. So we just draw ourselves a little triangle. We'll give ourselves some numbers, let's say 3.8 and 6 meters. Okay, and we label this one alpha, and just make sure we're working on a right angle triangle. So that looks like part of the roof that we're interested in. So I want to find tan of alpha. Okay, so if I want to find tan of alpha, I just need to know what tan of alpha is equal to. So tan of any angle is opposite over hypotenuse. We can get that from a rhyme. The last line of silly old Harry, caught a herring, trawling off America. So trawling off, did I write anything down there? Trawling off America. America is the adjacent. Trawling off America. So tan of alpha is opposite over adjacent, so trawling off America. Or the Sockatoa that we had earlier. Sockatoa. The toa part is the tan equals opposite over adjacent. Okay, so in our triangle we need to identify the different bits. Always start with the longest side, the hypotenuse. Okay, we don't know that one at the moment. Position yourself at the angle you're talking about and look into the strange triangular room, and there's my opposite alpha. Okay, so 3.8 is my opposite, and the side that gets left over, the side at the end, is the adjacent. This side here is adjacent, So the adjacent alpha is 6. So our opposite is 3.8. Our adjacent is 6. So tan of alpha equals 3.8 over 6. That's all we were asked for. 3.8 over 6. If you put that into a calculator, obviously it might give it to you as a simpler fraction that gives it as 19 over 30. Okay, or indeed you could 3.8 divide by 6, or 19 divided by 30, whatever you want, comes out as 0.63 recurring. Okay, recurring, that, don't leave that out. Anyway, we only have to do it as a fraction. So the second, we've kind of got that part done. The second part of our question, so first part's done, second part of the question, calculate the measure of angle alpha. Give your answer correct to the nearest degree. So we kind of go back to what we have here. We have tan alpha equals, I'm going to use 19 over 30. Doesn't matter which one you use. You can use this if you want, or you can use this. Makes no difference. So get the inverse tan of both sides. Okay, and so these, they're going to cancel out, leaving just alpha on the left. On the right, we just need to use our calculator, so it's shift tan. You should see the tan minus 1 on your screen. Be careful that you see it. And put your 19 over 30 or whatever you're doing in and hit equals. So again, just make sure your calculator is in the degree mode. You should be getting 32.3474435, blah blah blah. Okay, we're asked the nearest degree though, so the nearest degree here is 32 degrees. So alpha to the nearest degree is 32 degrees. So we've done that. Part 3, find the slant height of the roof BC. Now they're talking about slant height over here, they're talking about this bit here, aren't they? Okay, so in our particular diagram, they're talking about the hypotenuse, of course. So we want to know the hypotenuse. A few different ways you could do it. Maybe Pythagoras theorem is the easiest. So I'm just going to redraw my triangle down here. So my hypotenuse I'm going to label C. I know that's 3.8. That's 6. So according to Pythagoras' theorem, the long side squared is equal to the two short side squareds. Okay, and that's normally listed as listed as c squared equals a squared plus b squared. Okay, so but you can use the language long equals short side plus short side if you want. Don't know why I didn't put L in there when I was talking about long side. Okay, so anyway, you want to know that slant height, basically C. So my c squared is going to be equal to the 3.8 squared and the 6 squared. Now I just need to put those into the calculator. 3.8 squared, that's 14.44. 6 squared is 36. I'm going to add those together. So add on the 36 and I'm getting 50.44. Now I don't want c squared, I want to know just c, so square gets cancelled by a square root, so we want to use a square root here to cancel that square. So we'll do it on both sides, of course. So getting the square root of the answer we have, that's giving us c is equal to 7.1021 blah blah blah. Again, always ask answer. So said find the slant height of the roof. It didn't give us a certain number of degrees, so I'm just going to leave it as 4 decimals. So I'll stick in another decimal there. It was actually 12362 on my calculator screen. So if I'm looking for 4 decimals, I'm going to look at this digit here. Anything that's 4 or less means round down. So I'm going to keep that at 7.1021, correct to 4 decimal places. So that's 4 decimal places there. Okay. Right, so that's all, that's all that question's about. It's nothing particularly difficult. We just need to take our time and answer the question that's asked. Always worth checking back, check that you've answered the question that's asked. Does that kind of carry on, okay? So now, next example, use your calculator to find the following trigonometric ratios, correct to 4 decimal places. This could not be easier. So we just need to put these in the calculator. So if I was asked for, let's say, sine 20 degrees, cos of 23 degrees, and let's say tan of 81 degrees, I just put those in my calculator. So sine 20 is 0.34202, blah blah blah, and it did say 4 decimal places, so I'm looking at this digit, which suggests I should round down. The next one, 23 degrees, cos of 23 degrees is 0.9205048, blah blah blah. But again, I'm interested in 4 decimals, so I'm looking at the 0, and that'll give me 4 decimals there. Finally, tan 81, tan of 81 is 6.31375. Again, I'm looking at digit, just highlight the ones I was looking at. Looking at the digit to the right of my 4th decimal. In this case, because it's 5 or more, I'm rounding up. Excuse me. Okay, so we have a triangle here in part B. On diagram labeled side opposite or. So if I draw a very similar triangle, there's my or. Which side is opposite or? Start here and I just go bang. There's my opposite or. Okay, that's that labeled. Part 2, this label the side adjacent to or. Well, that's kind of easy enough. Again, I just start over here. I just look at the one there. Now, how did I know it wasn't the other side? Well, the other side is the longest one, so it's my hypotenuse. I should have labelled that one first, maybe, because it's the easiest one to label. Okay, but then we've answered to part 1 and 2. So it says if the opposite is 15 and the adjacent is 20, find the hypotenuse. So if the opposite was, we'll make up some numbers here. If the opposite was 10 and the adjacent was, let's say, 14, let's find my hypotenuse. Well, I'm going to use Pythagoras theorem again. So c squared is equal to a squared plus b squared. And of course, my c is my hypotenuse here. So it's my hypotenuse squared is going to be equal to the, it doesn't really matter which is which for a and b. I'm just going to label this one a and I'll label this one b, but it doesn't really matter. So sticking with that, it's going to be 10 squared plus, what's my b? My b is 14. It's going to be 14 squared. I'll forget the colour coding after this. So 10 squared is 100. So it's going to be 100. My 14 squared is 14. Yeah, 14 squared. I don't know that. Calculator says 196. Okay. So my hypotenuse squared is equal to 296. And again, I don't want to know what the hypotenuse squared is. I'm not interested in this squaring bit. So I'm going to have to use a square root to cancel that. So what's the square root of 296? Square root of 296 is 2 root 74 is the most accurate answer. So we could say the hypotenuse is equal to 2 root 74. But to get a feel for that in terms of decimal, I'll just change that to SD button to 17.2046. Question didn't ask for it to be left to 2 decimal places or anything like that, so that's actually the best answer there. This is not quite so good. It's not wrong really, so I shouldn't be marking it wrong, but this is definitely the better answer. Okay, so we'll leave that alone. Okay, so we've got a question here. There's a diagram with it. Kevin gave the following question to his class. Find the height of the slide, it says, and there's plenty of information on the diagram. We can see the slides running down at 50 degrees. You can see the legs of the slide are 20 centimeters. We should be able to find, height, I imagine. Let's take a look though. No, there's not enough information. There's not enough information. That's what it says here as well. No one could answer the question because there was not enough info or information. Put in an appropriate measurement on the diagram to complete the question. So let's say I've got a question like this. I don't know. It could be something like a boat is pulling a raft. Oh, I don't know. But there's also currents, pushing at the raft as well. So the current is flowing this way, I suppose. And the boat is kind of going this direction, I suppose. okay? So maybe I'll just show my boat over here a little bit. So even though the boat is going in that particular direction, the raft is not following directly behind. The raft is kind of following at an angle, isn't it? So there's one side of my triangle, and there's the other parts of my triangle, I suppose. Okay, so let's say we put some information in here. We've got 20 degrees. That looks ridiculous. That's maybe 80 degrees more like it. Okay, 80 degrees. So very similar to the slide, we've got 80 degrees in where the 50 is. I want to know the length of this section here. I want to know the length of this section here. Maybe we'll call it the drift. The raft is kind of drifting, not following directly behind. So I want to know how long that drift is for some reason. Okay, I have no idea. So we need to give some more information. We're going to need to know at least one more length. Maybe might make sense to give the length of this rope, perhaps. Okay, so I might say the rope is 20 meters, and then that problem is quite solvable. Now, without 20 meters, the problem can't be solved. But somebody else might say, oh, well, we might say that the horizontal drift, okay, we'll call the black one the vertical drift. You might say the horizontal drift is 4 meters or something. Then the question would be quite solvable too. So I prefer to give this though. Call that 20 meters. Okay. Right, so now we've done that sort of thing, kind of tick the box. We've added some information to the diagram. So a person could easily add the hypotenuse, I suppose, or they might add the adjacent to 50 degrees, whichever one they wanted to add. They could add some information there to answer part A. So put in an appropriate measurement on the diagram to complete the question. So that's all we have to do, just put a number in for the hypotenuse or for the adjacent to 50. Okay, using your measurement to find the height h in the diagram. Suppose if everyone's got a different measurement to put in, everyone's going to get different answers. That's okay. But we just need to find h according to our information. So we're trying to find our drift according to our information. Okay, so we better label the sides of the triangle. That's my hypotenuse. This side here is opposite. The drift is opposite the 80 degree. And so this side here is the adjacent to the 80 degree. So with that in mind, we can do our sine of 80, cos of 80, and tan of 80. And we're trying to do our opposite of our hypotenuse, our adjacent of our hypotenuse, and our opposite over adjacent. That's your silly old Harry caught a herring trawling off America, or your socket toe, or your some old hippie caught another hippie tripping on acid. Whatever rhyme you've learnt, you need a memory tool for that, I think. So you need to see what have we got. Do I know the hypotenuse? Yes, I do. So I know that, and I know that. I have the angle clearly, so I've got that for all of them. Do I know the adjacent? No. Do I want to know the adjacent? No, I don't really, not really interested in the adjacent. Do I know the opposite? No, but I want to know the opposite. That's my height in the slide question. So I want to know the opposite. So that's the bit I want to know. So the only formula that has 3 ticks is sine. So I'm going to use sine of 80. So sine of 80, now let's do that. Sine of 80 degrees should be opposite of our hypotenuse. So it's my drift length over my hypotenuse, which is 20. So now I want to be able to solve that. I will multiply both sides by 20. So go multiply both sides by the 20. Why am I multiplying? Because at 20 at the moment it's dividing, isn't it? It's on the bottom of the fraction, it's dividing. So if you, let's say drift is 5 for a minute, if we multiply 5 by 20 to get 100 and then divide by 20, we get back to 5. So anyway, our drift, we're going to get the answer for our drift, because 20, essentially that 20 divided by that 20 is going to be 1. Okay. Now sine 80 on the calculator. So sine of 80 on the calculator is 0.98. So that's just 0.98. But we're multiplying that by 20, remember. So multiplying that by 20, I'm getting the answer 19.696 meters. So it's drifting by about 19.696 meters. So if I'm asked for 3 decimal places, that's my answer. Bingo, done. Tick the box, done. Okay, great. Let's look at another question. Ken makes a clinometer using a protractor. A straw, a piece of string, and a small weight are used. Okay, so we can see we have the protractor drawn here, wonderful artist, the straw, and the weight and string are here. So all the bits of the clinometer, hopefully we understand that. Okay. He stands 8 meters from a tree. Okay, that's in the diagram. You can see the 8 in the diagram. And measures the angle of elevation. Okay, then we've labelled the angle of elevation there. I suppose he's looking up, you know, so there's your line of sight. Your angle of elevation is the way, you know, you're looking up a bit. So there's my angle of elevation in there. So that's easy enough to get, I suppose. Now on the clinometer, I should say, the clinometer, which angle is the angle of elevation? Is it this one here where the arrow is pointing to, or is it this one over here? Well, that's kind of a bit confusing when you're learning it first. It's the one where it's pointing to. Now be aware of questions and problems in books or videos where sometimes accidentally somebody points to here. Okay, they shouldn't be pointing down here for the angle of elevation in this type of situation. So just be aware of that. Sometimes you get questions that point to the wrong thing. Look, it's not a big deal. So anyway, so find the angle of elevation by reading the clinometer above. That's what the first question says. We need to read the clinometer. There's no measurements in this thing. So how are we supposed to read it? Well, maybe we can kind of estimate a bit. So there's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. There's like 17. Oh yeah, and of course all the way around the last one would be 18 there. So your 0 is here and you've counted 18 rounds. So that looks to me like each of those ticks is 10 degrees. Okay, so 10 degrees for each of those. So how many of them have I got? Well, if that's the case, let's try and zoom in here. Which case that's like 10, 20, 30, 40, 50. So it's halfway between 40 and 50 by the looks of it. Okay, halfway between 40 and 50 makes, to my head, an estimate 45 degrees. Okay, so that thing's 45 degrees, roughly. It's only an estimate. Find the angle of elevation by reading the clinometer above. Okay, that particular diagram, it looks like about 45 degrees. If you've got an estimation question like that, you just got to go with what's in the picture. Calculate the height as shown in the diagram. Correct 2 decimals. Okay, that's kind of easy enough to get at that height. That height is just right from a triangle. So let's do a similar triangle, and you guys can practice that one in a second. So let's say that's a horrible diagram. Let's try that again. Okay, let's try and do a slightly better triangle now. Okay, that's not too far. It kind of looks like 45 degrees. Okay, so we want to know the height here of this triangle. So I want to know that height, and I have an angle of 45 degrees. So in our question, we'll just make the bottom of the triangle equal to what? 8 meters. No, 6 meters. 6 meters. I don't want it to be the same as that last question. Okay, so I have enough information here. I just need to figure out which am I going to use. Am I using sine, cos, or tan? So sine of my 45, is it going to be cos of 45 or tan of 45? Which one's going to help us? Sine is always opposite over hypotenuse. Cos is always adjacent over hypotenuse. Tan is always opposite over adjacent. Let's label a triangle. That's the hypotenuse. If I stand in this corner of our weird triangular room and look across into the room, I'm looking at the opposite side, or I should say opposite of 45 degrees. And this side here then, the one that's left, has to be adjacent to the 45 degree angle. Okay, so do I know the angle? Yes, of course I do. I can work with that angle. Do I know the opposite? Well, I don't know it, but I kind of, that's the one I want to know. That's the height I want to know. So yeah, I'm happy to work with opposites. Do I know the hypotenuse here? Don't know the hypotenuse. Okay, so it looks like sine and cos are out. Do I know the adjacent? Yes, that's 6. Great, so let's, which formula has all 3? Tan has all three ticks, so we'll work with that one. Okay, so I'm working with tan 45 degrees, my opposite over my adjacent. That's my h is my opposite, and my adjacent is 6. Look up tan 45 in the calculator, that's 1. So 1 is equal to h over 6. Let's say I multiply both sides by 6 then. That's easy enough, just multiply by 6. Again, because that's 6 is dividing, so we're going to multiply both sides to get rid of it. So 1 by 6 is 6. What happens if you multiply that thing by 6? The same thing. If you imagine I'm multiplying by 6 there, getting 6 divided by 6 gives me 1. Okay, that's why they cancel. Don't like saying cancel. 6 divided by 6 is 1, so we're really getting 1h here. That's what we want. So if the question is in meters, it is, yeah. If the question is in meters, then that is 6 meters. Always answer the question that's asked with the units that's asked. Calculate the height shown, 2 decimal places. Well, ours worked out perfectly as meters, so find the total height of the tree. Well, that's kind of, how do I find the total height of the tree? Well, if this person was 1.8 meters, you'd add on 1.8 over there. Let's say our person is only 1.6 meters tall. So if the person is 1.6 meters tall, we're going to add on the 6 meters above their eye level to get a total of 7.6 meters for the height of the tree. Okie dokie. I can barely read this. It says label opposite, adjacent and hypotenuse in this triangle. Well, that's damn easy. The hypotenuse is always the longest, yes. We're talking about the hypotenuse here. Talking about, there's my opposite, so this one here is my opposite, yeah. And the one that's left, of course, is the adjacent, so we could label that adjacent. So that's to kind of carry on there. Easy enough. Fill in our ratios. Opposite of a hypotenuse, this couldn't be easier again. Opposite of a hypotenuse, that's just sine, isn't it? Just need to know your rhyme there to that sine of theta, or sine of a, which you prefer. I suppose they've used cos of a down below, so we'll use sine of a. So again, silly old Hardy, that's my sine opposite hypotenuse. So cos is adjacent over hypotenuse. Maybe write them out fully if you're in an exam. So cos, that's my rhyme, caught a herring. C for cos, A for adjacent, H for hypotenuse. And the last one is tan the angle is opposite over adjacent. So that's silly old Hardy caught a herring trawling off America, or some old hippie caught another hippie tripping on acid. And so the last one, God, I can barely read this. I've got a triangle with an angle T and 21 centimeters. It then tells if the angle is 38 degrees and the opposite is 21 centimeters, find the length of the hypotenuse to the nearest centimeter, I think it is. So if we take a question similar to that, okay, so we can take a little diagram here where we have an angle. Well, they told us the angle, so let's just put in an angle 32 degrees. I think they told us the opposite, wasn't it? The opposite was 21, yeah, so we'll make our opposite 43 meters, or centimeters, let's say. Okay, centimeters we'll go with. And we want to know the hypotenuse, isn't it? Yeah, find the length of the hypotenuse. We'll find our hypotenuse, thank you very much. The hypotenuse is the longest side. I should label the right angle. So what have we got so far? We have the angle, and we have the side as opposite the angle. So we have a side that is opposite the 32 degree angle. Okay, I can barely read that. So anyway, and of course we don't know the adjacent. I suppose that's what we're kind of saying to ourselves. We don't know the adjacent, so we're not going to be using that. Just hard to read that, so I'll just put in opposite the 32 degree angle. Okay, so again we're off to write down our sine, cos and tan. Keep writing them down until you get really good at these questions. Taking shortcuts when you're learning is only going to lead to bad outcomes. Okay, so silly old Hardy. So old Hardy is telling me opposite of our hypotenuse. Caught a herring. A herring is telling me adjacent of our hypotenuse. Trawling off America. So off America. That's opposite over adjacent. So do I know all these bits? Well, I don't know the hypotenuse, so that's x and x. Looks like they're out of the picture already. I do know an angle, of course. Bing, 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 bing. Okay. I do know the opposite is 43, so I can put in 43 there, and I do not know the adjacent. Oh, hold on, don't know the adjacent. I'm going to go back. I kind of made a mistake. You can see I've got x's everywhere. While I don't know the hypotenuse, I do want to know it. So I want to know this one. That's the one I want to know. Should have marked that early on. So I'm going to put a tick beside the hypotenuse on two of the formulas. There and there. So which formula has kind of three ticks or three useful pieces of information? It's the sine one, isn't it? So cos I don't know the adjacent, tan I don't know the adjacent, and I'm not interested in knowing it. So yeah, I could figure it out. I mean, I could use that, but I just don't want it now. The bit I want to know is the hypotenuse, so I'm working with sine. So I'm working with sine 32 is equal to 43 over h. So sine 32 is equal to 43, which is my opposite, over my hypotenuse. That's what I want to know. It is a little bit trickier than some of the other questions you can do, because the unknown's on the bottom of a fraction. Just makes it a little harder. It means there's two steps involved. So we'll get sine 32 first, because most people prefer to work with decimals. So I'm just going to put down the sine 32. Again, you keep the number on your calculator. I've written down 5 decimals there, but there's more. Okay, so that's my sine 32. Now, again, maybe rather than writing hypotenuse, maybe we'll just write in h or x or something, just so that it's a little neater. Now, again, we've got a fraction. The x is on the bottom of the fraction. Remember, fractions are always top divided by bottom. So this thing is dividing by x. So if I don't want x there, I'm going to have to multiply by x. Multiply by x, okay. It's always doing the opposite. So I'm left with 43 on the right hand side. How am I left with 43? You might wonder. You can see my x is multiplying and the x is dividing. So there is my number 1. Okay, so it's kind of like 1 times 43 is just 43. You don't need to write that stuff in red or any of that fraction in purple there in the middle. We don't need that. Just need to maybe write down something like this so that we're showing the examiner what we're doing. Okay. Now, at this stage, this is a multiplication. The decimal 0.5299, that's multiplying my x. So if it's multiplying x, I need then to divide. So I'm going to divide because, again, I'm seeing multiplication, so I'm dividing by that decimal. Now, like I said, you keep the decimal on your calculator or just type in sine 32 again, whichever. Just people don't like writing sine 32. People, generally speaking, are happier with the decimals. Okay. So again, if you divide a decimal by itself, you're going to get 1x. So I'm getting 1x on the left, or just x. So the bit I can do in the calculator is 43 divided by my decimal. So it's 43 divided by 0.52991. I'll be ever so slightly off if I just use that. Not so much. 81.14585 is probably accurate enough for most things. Again, if I want to get really accurate, I'll just do 43 divided by what was a sine 32. If I divide it by sine 32, there probably won't be any real difference. So the more accurate answer is 81.1444364. It does make a bit of a difference. This is the better answer because I used sine 32 rather than rounding off. Again, don't round off. Keep the decimals on your calculator or just go back and type sine 32. Okay, now did the question ask for anything to the nearest centimetre? Wouldn't make much difference here in this case because to the nearest centimetre, both answers give the same answer. So 81 centimetres to the nearest centimetre. Does it look reasonable? Yeah, I guess so. So that looks good. Okay, there's just a few little examples that might be useful if you're learning basic trigonometry. So I hope we got a bit of everything in there, using inverse functions, the idea of using a clinometer. There's loads of videos on YouTube with clinometers that are really nice to watch. Get you the idea of why we use them, how useful they are. And we've used a mixture of sine, cos and tan and Pythagoras' theorem, so hopefully you found it helpful. Thank you. Bye bye.